Good afternoon, everyone. So welcome back after the Easter break. I hope you've had a good time. I hope everyone's kept safe and enjoyed the sun sensibly and all that sort of thing, and that you're eager to go. I know it's Easter Monday and we should still be on holiday really, and if you want to catch up with this later in the week, then that's fine. But I did want to keep us to this idea of having 3 lessons of pure every week on a Monday, Tuesday and a Wednesday, leaving you with 2 days, Thursday and Friday, to do a lesson each for statistics and mechanics with Mr. Cooper. And today's quite an exciting start, because we're going to be starting looking at the gradients of curves, which is where the whole mathematical field of calculus starts, and it's something that's very relevant in all sorts of things, and especially as you see everything on the news over the coronavirus, and they'll be talking about how they're using mathematical models to work out how the virus spreads. Anything to do with the rate of change and exponential growth can all be keyed into graphs, and they will be looking and using calculus in order to make the best predictions that they can, and to see which countries are responding in the most effective way possible as to how well they're managing to stay off the slope that would happen if no prevention was taken care of. Okay, so let's start. At GCSE, you may well have remembered estimating the gradient of a tangent to a curve as something that we've done quite a few times. And when you did that, you may have thought, but what exactly is the tangent of the curve? Is there a way to work that out? And yes, there is, and that's what we're going to be starting to look at today. So you'll like to pause the video now and just make a copy of the diagram that's there. It's the same thing as what's in the textbook, but it's just fitting the squares in your books better. And when you've done that, the first question that we need to do is to calculate the gradient of the tangent t. And in order to do that, we just need to look at the points that we actually know here, because it's been drawn on here for us. So we've got one point here, which is 0.11, and we've got another point here, which is 2, 3. Now when we work this out, we could do it by saying, well, I've gone along 1 and I've gone up 2, therefore the gradient is 2, and that's easy enough to do that way. But we need to do it algebraically, because things will get trickier on other ones. Y equals x squared is the simplest curve we could have. So the first point here, 1, 1, we're going to be considering that as calling that the points are x1 and y1, and the points up here, 2, 3, is our second x value and our second y value. So we're calling that x2 and y2. And in order to work out the gradient of t, I need to divide the difference in the y's by the difference in the x's. So I will take my second y value, or I will take my first y value away from the second y value. So that would be 3 take 1, and on the bottom I've got my second x value take away the first one, the one I'm coming from, so that gives us 2 take away 1. We could do it the other way round, but we'd have a negative divided by a negative, giving us a positive, just a little trickier. 3 take 1 is 2, 2 take 1 is 1, so 2 divided by 1 means the gradient of t must be 2. Right, so here's question B. Calculate the gradient of the chord AP, so that's this line here, joining a chord being a straight line that joins 2 points of a curve or circle together, when P has coordinates, and we've got different coordinates, 2, 4, so 2, 4 would be there, 1.5, 2.25, so that would be about there, 1.1, and so on. And why are we being asked to do this? Well, it's because we're trying to find out how we can algebraically find the gradient of a tangent at any point, and we're thinking about this point 1, 1. And the first chord that's been drawn on here, you can see is significantly steeper than the gradient of the tangent that we want. But if I was to draw in 2, 4, the first one that they're asking us to calculate, that would give me a slightly less steep line, but still steeper than tangent T. If I went to 1.5, 2.25, that's about there, I'm again getting closer to the gradient that I want. If I go to 1.1, that's just going to be 1/10 of the way along. It's going to be a very, very short one, but if you think about it, the steepness of that slope is going to be closer to it. And 1.01, just 1/100th of the way along, is going to be almost exactly the same as the gradient of the tangent. And then the last thing we're going to do is we're going to consider any value that we're putting on here. So we'll come to that when we get there. But starting with 2, 4. So when we're thinking of the gradient for 2, 4, the gradient m is going to equal my second y value being 4, take away the 1 because we're always going back to this point 1, 1. 4 take 1 over 2 take 1, which gives us 3 over 1, which is 3. Then we move on to 1.5, 2.25, and the gradient this time will be 2.25 take 1 over 1.5 take 1, which gives us 1.25 over 0.5. When I divide by a half, it doubles, so that's going to give me a gradient of 2.5. So it started at 3, it's come down to 2.5. Remember, we actually want that answer to be 2 in the end, because that's what we know from the tangent that we've been told exactly where it is beforehand. Moving on down, we get to the third one, and we just do the same process again. So I've got 1.21, which is 1.1 squared, because this is the curve of y equals x squared, so your y value is always going to be your x value squared. So 1.21 take 1 is 0.21, and that's going to be over 1.1 take 1, which is 0.1. Dividing by 0.1, that's timesing by 10, so that's going to be 2.1. And the fourth one is giving us 1.01, 1.0201. So the gradient is going to be the 1.0201 take 1 over 1.01 take 1, giving us 0.0201 over 0.01. That being 100th, dividing by 100th times by 100, that's going to give me 2.01. So it does look like we're getting closer to 2. And on the last one, where it goes into algebra, and we're saying, right, we can consider any value at all. 1 plus h is my x value, and 1 plus h squared is my y value. So that would give me on the top 1 plus h squared take 1 and 1 plus h take 1. Now that's quite simple. On the bottom's definitely going to leave me with h. In order to work out what this is, I need to do consider what 1 plus h squared is, and it's not too tricky, is it? It's just like x plus 1. 1 squared is 1, plus you're going to have 2h and h squared when you expand that bracket. So if we take 1 away from what we've expanded from that bracket, we are left with h squared plus 2h. Now there's different ways you can simplify that. You could say I divide everything by h, or you could, one nice way of doing it is you could factorize the top, which would give you h plus 2 inside the bracket there over h, and then you can simplify by dividing top and bottom by h, and it gives you h plus 2. So your gradient is always going to be 2 more than h, which was the amount more than we started with there. Now what that means is, as h tends to 0, so as the length of our tangent gets closer and closer to 0, the gradient is tending towards 2. And if you look at question C on the example, it asks you to comment on the relationship between your answers to parts A and B, so these answers in here, and that comment is actually what I've just written there. As h tends to 0, the gradient is tending towards 2. Now strangely, there are only 4 questions in today's exercise, but I just want you to do the third and fourth. They're actually more straightforwardly like what we've just done, and I think it's a good idea to focus on that. If you think you've all got it all and you'd like to have a stab at questions 1 and 2 as well, then by all means do. But what I want to be sure of is that for now you've got this. If you haven't got it, do let me know, but hopefully tomorrow's lesson and what we do going forward will gradually get a little bit simpler, and it's all good stuff. Okay, right, enjoy that. See you all tomorrow. Bye bye.